All right, so we're going to continue graphing out some quadratics here. So we can just go ahead, since kind of thinking about our parent function here, sitting here at 0, 0, 1, 1, negative 1, 1, 2, 4, 1, 2, 3, 4, negative 2, 4, 1, 2, 3, 4, and graphing my nice parent function. And then thinking about it being moved, this plus 1 here on the outside here means it's going to move up 1. And then this negative on the outside here means it's going to flip upside down. So I'm going to flip it upside down. So it's 4 from here, so it's be 4 from here. 1, 2, 3, 4. 4 up here, so 4 down here, 2, 3, 4. Connect those. There it is, upside down. And we also have to move everything up 1. So moving this up 1, moving this up 1, moving this up 1, moving this up 1, moving this up 1. And there's our new graph. So this one here is y equals negative x squared plus 1, the blue graph. So, and we're supposed to also find the y-intercept. So it's equation of my vertex is sitting there at 0, 1. We're supposed to find the y-intercept. And it's just your c value there, which is 1. And then, do we have anything else we have to identify there? Nope, and just graph it. We graphed it. So it says for each of these, find the coordinates of the vertex, the y-intercept, and graph it. So you can look in here and you can see what your vertex there. This is, remember, it's in this form of a times x minus h squared plus k. And our hk here is our vertex. So our h here is going to be 1. And our k value here is going to be negative 3. So, and again, let's graph out our parent function if we want, which is 0, 0, 1, 1, 2, 4. 1, 2, 3, 4. Negative 2, 4. And then we can do everything we're supposed to do here. We're supposed to move it to the right 1 and down 3. So right 1, down 3. Right 1, down 3. Right 1, down 3. And we can do the same thing here. Right 1, down 3. Right 1, down 3. Oh, this should have been negative 2, 4. Graph that so fast. Negative 2 and up 4. So then right 1, down 3. Should have been right here. You can kind of tell sometimes you mess up because you can see where your ordered pairs are supposed to be. So there it is so far, but then we got that 2 there on the outside. So what that's going to do is going to change the steepness of our graph here. So it'll still stay here. And then we're going to go ahead and figure out how that's going to change the steepness of our graph there. So our vertex here is still 1, negative 3 here. But then we've got our, this is going to stay here. We're going to multiply. It's still going to be negative 1, and then it's still going to be 1, and then it's going to go up 1 here, but it's going to be negative 1 and then up 2. So kind of think about it changing your slope here. This one here is still over 1, but then up 2. And then this one here, if we wanted to do this one here, this one would be, you know, still over 2, but instead of being up 4, it'd be up 8 because you double whatever it's supposed to be going up. So we could have done that as well. So if we would have gone 2 and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. And then same thing here, over 1, up 2, and now over 2, and we're going to go up 8. And then connect those with this. So we could, so your y values there, you're going to multiply by 2. And then it says, what's the y-intercept? If you don't see it, we can go ahead and just substitute 0 in there. So y equals 2 times 0 minus 1 squared minus 3. So you get 2 times negative 1 squared minus 3. This gives me negative 1 squared there is 1, and 1 times 2 there is just 2. And we got minus 3, which gives us negative 1. So our y-intercept there is negative 1. And you can kind of see that on our graph too. It's where it hits the y-axis there. It's up there at 1. So for this one here, you can kind of think the same thing. If I write it in that form vertex form, y equals 3 times x squared minus 4 here. So I'm going to write the equation right underneath. It goes a times x minus h squared and then plus k. Well, what's happening in here, your 3 is your a value, and then inside here you're not subtracting anything. So if you want to put a 0 in there, that's what it would be, and then minus 4. So what's my h and what's my k? My h here is 0, and my k here is negative 4. So 0, negative 4 is going to end up being my vertex there. And then we could find our y-intercept as well. Remember, to do that, we can just let x equal 0, so I can go 3 times 0 squared minus 4, which gives me 0 minus 4, which ends up giving me negative 4. So again, we could graph this out just using our parent function 0, 0, 1, 1, negative 1, 1, 2, 4, 1, 2, 3, 4, negative 2, 4, 1, 2, 3, 4. Connect our points. So we got a couple different things here. We got to multiply our y's here by 3. So 0, 0, this is 1, 1. Now I'm going to multiply the y value of this, which is 1 by 3. So it's going to be 3, so it's going to be 1 and over and 3 up. That's what this 3 here in front here does. And vertically, it's going to make it narrower here. So negative 1, instead of being up 1, it's going to be multiply the 1 value here by 3, which gives us 3. And then this one here is negative 2, 4. So if you multiply your y value there by 3, there you get 12. And that's going to be off my graph. So I'm just going to stick with those 3 points there. And then our last graph here, we're supposed to shift everything down 4. This is a vertical stretch of 3. And this is down 4. So moving the blue graph there down 4. 1, 2, 3, 4. Moving this blue graph down 4. 1, 2, 3, 4. 1, 2, 3, 4. Connect my points. So this ends up being y equals 3x squared minus 4. So we've got our vertex, we've got our y-intercept, and we've got our graph there. And you can see your y-intercept there is at negative 4, and so is your vertex is also at 0, negative 4. This one here says write the equation of this one here. We're going to translate, each equation is a relation of y equals 2x squared, write a function for the graph. So your 2x squared just makes it a little narrower. So if you kind of think about it being graphed out here, I'll graph out y equals 2x squared, be 0, 0, and then your next one here would be at 1, 2, and negative 1 and up 2. So that's your normal parent graph of y equals 2x squared. Then that one there is just being completely translated, because you could see from the vertex here, you're moving 1 over and 2 up, 1 over and 2 up, 1 over and 2 up. So where's the vertex at? It moved 1, 2, 3, and up 2. So it went 3 this way, and then 2 up. So 3 right, and then 2 up. So kind of thinking through that, using y equals 2, how do I get 3 to the right? X minus 3 squared, and then 2 up, it's plus 2 on the outside. Let's look at another one. Again, this one's y equals 2x squared, so think of the parent graph 0, 0, and then 1 over and 2 up. So now coming over here and looking here, yeah, you're still going 1 over and 2 up, 1 over and 2 up. So the value there on the outside there hasn't changed. So now let's think about how we moved. Well, we moved it 1, 2, 3, 4, and 1, 2, 3. So 4 this way and 3 this way. So what is that? 4 left and then 3 down. How do we write that? That's going to be x plus 4 squared minus 3. And we got one more of these. Let's try one more of these. Again, kind of think about your parent function sitting right here, 0, 0, 1 and up 2, negative 1 and up 2. So that graph's being moved. It's still going 1 over here and then down 2, 1 over here and 2. So we're going to move this thing. How is it being moved? It's being moved 1, 2, 3, 4, 5. So it looks like 5 and then down 1. Still 5 left, 1 down. And then look too, the graph here is upside down, flipped. So how do we write that? It goes y equals 2 times x plus 5 squared and then down 1. But we also said that it's flipped, so it has to have a negative here on the outside, so I got to put a negative 2 in there. So that's flipped upside down, move 5 to the left and 1 down. So you can go ahead and continue working on that. Hopefully that's helped you to see what the equations of the graphs now are.